All right, let's talk about a situation every developer knows. You write some code, it works perfectly. But when you come back to it 6 months later, it's completely unreadable. We've all been there. So in this explainer, we're going to dive into an industry classic, Steve McConnell's Code Complete, to learn how to write software that doesn't just work today, but is clear and maintainable for years to come.
So let's start with that fundamental question. Why is it that code can pass every test, get deployed, and still become this fragile, confusing liability over time? The kind of code that makes you afraid to touch it. This is the core problem we need to solve, and the answer has everything to do with structure.
To get there, here's our roadmap. First, we'll look at why just working isn't good enough. Then we'll define what good structure actually is. We'll cover the core principles, look at common mistakes to avoid, explore how professionals think about this, and finally, we'll wrap up with some practical takeaways you can start using immediately. Okay, section 1. Let's talk about the hidden costs. When you're on a deadline, the most urgent goal is just to make the code work. But that intense focus on the short term often blinds us to the long-term consequences, which, as it turns out, are far more expensive. Now, this chart really puts things into perspective. According to the research in Code Complete, fixing a bug after a product is released can be 10 to 100 times more expensive than fixing it during the initial development. As you can see, that first push to get the code working is just a tiny fraction of the total cost. The vast majority of the expense comes from maintenance over the software's lifetime, and it's poor structure that makes that maintenance so difficult and costly. So if structure is this important, what exactly are we talking about? It's really not about knowing the specific syntax of your programming language or following some arbitrary style guide. It's a much more fundamental concept. According to McConnell, the #1 technical priority in software development is managing complexity. Our brains can only hold so much information at one time. Good structure is what makes a program intellectually manageable. The goal isn't to write something so complicated that you can't see the bugs, but to write something so simple that it's obvious there are no bugs in the first place. So good structure is built on these 4 pillars. First, a logical organization. Related pieces of code live together. Second, clear responsibilities. Every part of the system, whether it's a function or a class, has one specific, well-defined job. Third, the flow of the code is predictable and easy for someone else to trace. And maybe most importantly, you always prioritize readability over some clever, complex trick that no one else can understand.
All right, let's get into the building blocks. These are the core principles that help us achieve that good structure we just talked about. Think of these less as rigid rules and more as powerful heuristics that guide your decisions.
The 2 most important ideas to grasp are cohesion and coupling. High cohesion means you group related things together. Everything inside a single module should be tightly focused on one single task. Low coupling is the other side of that coin. It means you minimize the connections between unrelated modules so they can operate as independently as possible.
A great analogy is a well-organized toolbox. All your wrenches are in one section. That's high cohesion. You can grab any wrench you want without affecting the hammers. That's low coupling. The opposite is one of those all-in-one multi-tools. It seems convenient, but if the screwdriver bit breaks, the pliers might become useless too. Everything is tangled together. Next up is a really critical concept, information hiding or encapsulation. This is all about identifying the parts of your design that are most likely to change in the future and then hiding them behind a stable interface. This protects the rest of your program from having to change when that one detail inevitably does. And here's a perfect, simple example. On the left, the logic for generating a new ID is just out there. If you ever want to change how IDs are created, you have to find and change every single line of code that does this. It's brittle. But on the right, that logic is hidden inside a new ID function. Now the internal implementation can completely change, and the rest of the code is totally unaffected. This is how you build robust, adaptable software. And finally, let's talk about control flow. Deeply nested if statements and loops create a huge mental burden. To understand what's happening, a developer has to keep track of a whole tree of conditions in their head. This complexity is a breeding ground for bugs. The professional approach is to always aim for a flatter, more linear flow that's easy to read from top to bottom. Okay, so we've covered the principles of good structure. Now let's flip it around and look at what happens when these principles are ignored. Recognizing these common anti-patterns is the first step to fixing them in your own code. Here are a few of the usual suspects. A God class or God function is the ultimate example of low cohesion. It's one giant blob of code that tries to do everything. Spaghetti logic is what results from an untangled, unpredictable control flow that jumps all over the place. Excessive conditionals are a classic sign of deep nesting and unmanaged complexity. And finally, over-engineering. That's when we create abstractions that are actually more complicated than the problem we were trying to solve in the first place.
This leads to a really important realization. Good structure doesn't just happen by accident. You can't just add it in at the end. It's actually a result of a professional mindset, a deliberate way of thinking about the entire process of writing code. So what does that process look like? Well, first, professionals invest time upfront in requirements, in architecture, before they even start coding. They refactor constantly, viewing good structure as something you maintain, not something you create once. They always optimize for the next person who has to read their code. And maybe most tellingly, they prefer boring solutions. They choose simple, obvious, and predictable code over a clever trick every single time, because they know that boring code is understandable and maintainable code. So let's bring this all together. How can you apply these ideas in your own work starting today? Let's distill everything down into a few practical, actionable rules.
Here's your checklist for better structure. Make your routines and classes do one thing, and do it well. That's high cohesion. Hide the messy details behind clean interfaces. That's information hiding. Actively work to minimize the connections between different parts of your system. When you see messy code, don't just leave it, refactor it. And before you write a single line, always stop and ask yourself, what is the absolute simplest way I can solve this problem? And as we finish up, I want to leave you with a question to think about. Consider the last piece of code you wrote. If a brand new developer joined your team tomorrow, could they look at that code and figure out what it does without you having to sit there and explain it all? The answer to that question is really the ultimate measure of its structural quality. Because in the end, it all comes down to this powerful idea from McConnell. The computer will run almost anything. The real challenge, the mark of a professional, is to write code that communicates its intent clearly to other people. Write for people first, and the rest will follow. Thanks for watching.